Hello, everyone. My name is Harris Peter Baskaran. I'm from Google. It's a pleasure to be with you here today at Conf42 DevOps 2026. I'm a staff SRE at Google and I have been with Google for 11 years. Today, I'm excited to share about a comprehensive case study titled From Lift and Shift to Kubernetes, a two-phase DevOps modernization. This talk is not just about moving workloads to the cloud. It's about the strategic evolution of a mission critical enterprise application. And we'll explore the technical hurdles, the strategic decisions, the operational outcomes of such a large transformation. This transformation is for a legacy ticket management system, and we'll transform this through this journey into a high performance cloud native service. Every cloud migration is a journey with many learnings. And whether you're starting your journey now or you're knee deep in the trenches of Kubernetes, I hope this blueprint serves as actionable insights for your modernization efforts. To understand our journey, we should start at understanding the challenge. The existing service was an on-prem service running on VMware and had been running for over 2 decades. It was a large monolithic application, tightly coupled with many integrations. This was one of our core business function services that is used day in and day out for more than 100,000 tickets every single day. When this tightly coupled monolith application service stops, the business stops. The was upgraded more than a decade ago from on-prem physical machines to VMware. And for more than a decade after that, it was not upgraded at all. When this project started, it was running on aging VMware infrastructure and had a very large Oracle database at the backend. Both the cache, the application stacks were globally deployed to reduce latency for users. Over the years, the architecture has devolved into complex web of interdependencies, along with growing number of customers and other critical systems that depend on this. The technical debt made even minor updates risky and time consuming. Every single operational change was a bottleneck as the transaction volume started growing. The complex dependencies made everything such as even a routine maintenance, such as patching, software upgrades, and any releases a challenging thing to do. So our goal was very clear: transform this monolith into a containerized platform, minimizing disruptions. But we needed a method which was methodical, measured, and above all, risk averse. So we came up with this two-phase strategy. To manage the risk, we decided against a big bang approach. The two phases were phase one, which was a lift and shift. The lift and shift to Google Compute Engine. The objective was very simple. So move the existing architecture from on-prem into Google Compute Engine as is. Why do we do this? Because it allows us to exit the VMware infrastructure more quickly. And more importantly, it allows us to establish a performance baseline for the cloud environment. We wanted to see how the app would behave in a cloud infrastructure before we added the complexities of containers. We preserved the existing architecture as much as possible. The goal here wasn't innovation yet. It was more about stability. So by moving the VMs into cloud, we could let go of the dependencies of VMware and establish a baseline performance for adding the complexities of containers later on. Phase two was more about the modernization, the cloud native transformation. Once we were stable on GCE, the hard work of containerizing the application, moving it into GKE, and then solving the data layer problem, we could approach this more as a phased approach. It'll allow us to isolate the variables that change and ensure that if anything goes wrong, we could easily pinpoint which layer of the stack was responsible for the issues. So let me delve a little deeper into phase one. Phase one was all about precision. So we broke it down into 4 critical steps: dependency mapping, parallel deployment, continuous replication, and almost zero cutover time. In dependency mapping, we didn't just look at the code. We looked at the network. We used the discovery tools to map every integration point and communication patterns. You'd be surprised how many zombie services or undocumented API calls exist in a 10-year-old monolith. We then use this data to chart out all the dependencies and understand systems it depends on and systems that dependent on it. Secondly, we built the cloud environment as a parallel environment to the on-prem environment. This wasn't just a sandbox, it was a mirror. This parallel deployment made sure that the live service was never disrupted or ever impacted. Thirdly, continuous replication. We used Oracle's native replication technology to keep both the cloud databases in sync with the on-prem VMware environment. This ensured that when we were ready to move the data, when we were ready to cut over, the data was already there. This was very necessary because the database, as I mentioned, was a very large database. And finally, about the cutover. We use DNS and load balancer redirects to make sure that the traffic was moved over in a controlled manner. Because the environments were identical in architecture and the stack, the data was kept in sync when we were ready to cut over. We also had the option to fall back very easily if we needed to. And keeping the data in sync all the time made sure that the cutover is only a matter of minutes. How we measured the success of phase one. So, as I mentioned, phase one was a very critical step in our journey. Once we were on GCE, we didn't just keep the lights on, we measured everything. We gathered comprehensive baseline metrics on application latency, system throughput, resource utilization, and we know exactly how the monolith performed on cloud. These numbers gave us our success criteria for phase two. So we essentially set a bar for our future Kubernetes system that had to, and that bar we wanted to either meet or exceed through the transformation. So our immediate win with phase one was more about rapid resource provisioning on cloud, scaling, improved performance on GCVMs. And given the dependency mapping work that we had done in phase one, we had a lot more efficient maintenance operations after phase one. Phase two was the Kubernetes transformation. With our baseline established and stable, we entered phase two, where we got the opportunity to do the cloud native redesign. This was the modernization phase, as I mentioned. We wanted to make sure that the service could serve the business efficiently for many years to come. And also, we wanted to take the opportunity to use all the cloud best practices and cloud SRE tools available. In this phase, we transitioned from VMware machines to cloud VM machines to containers. We moved the workload to Google GKE and began the work of modernizing our data layer, which is the Oracle database into Postgres. This phase allowed us to finally unlock the benefits of DevOps, like I mentioned, rapid scaling, automated recovery, a streamlined CI/CD pipeline, improved security, and many more. And I'll talk about all of these in the coming slides. On database migration, this was perhaps, I would say, the most hardest hurdle for us, from moving from Oracle to Cloud SQL, PostgreSQL. This was not a simple export import. Like, we'd had to rewrite a bunch of the PL SQL packages. This was custom, manage complex time zone conversions, character set misalignments, handle data type display. And given the size of the data, this was not a trivial challenge. That required a lot of careful planning and execution, which was many months in the making. We utilized change data capture to keep the databases in sync during the transition. It required a lot of cycles of doing performance tuning and multiple rounds of load testing to ensure Postgres could match the high concurrency throughput of the original Oracle environment. And being on cloud, we could spin up resources in a matter of minutes, run a load test, and destroy them. So using Terraform, we declared our whole stack, and that made cloning for load testing environments a lot easier. For monitoring and troubleshooting, we used cloud native monitoring toolings, which was a huge advantage here. Next, I'll talk a little bit about security. On Kubernetes, security is a zero trust game. So we implemented fine-grained network policies to control pod-to-pod communications. On-premise, we had to rely on a hard perimeter, but in GKE, we controlled over 200 distinct communication paths. So the dependency analysis we had done in phase one helped us land this fine-grained network security boundary definition in phase two. We started from a less restrictive network policy definition, and as we monitored the traffic, we made this more restricted with fine-grained protocol-aware segmented traffics. The cloud-based tooling made this possible. On GCP, we have fantastic network traffic monitoring software, allowing us to map all the routes, gave us a lot of deep insights, and made traffic monitoring possible and much, much easier. Now let's talk about disaster recovery. In a legacy environment, DR was a large and manual and high anxiety process. It involved periodic backups, measuring recovery times in hours and even days. And we rarely tested a full scale scenario because we were not confident of getting to a recovered state. When we moved in phase one, our DR strategy matured because we moved from manual backups to automated persistent disk snapshots, and we were able to restore them and test them. And this was a huge step forward because we were able to document everything and have automation to do the spin up of new VMs, reattaching disks, and reconfiguring networks. Once we reached phase two with GKE, our entire DR philosophy changed because we moved from a model of recovery to a model of resilience. So in GKE, we implemented a multi-region deployment strategy, and we used GKE's natives capabilities for backup of GKE, ensuring that our container configuration secrets and stateful datasets were all replicated across geographic borders. And then we had infrastructure as code, like I mentioned, which helped us rapidly build and deploy environments. I want to emphasize the importance of a full scale recovery exercise. As part of our launch, we did a bunch of what we call wheels of misfortune, where we test out the recovery of the system. That allowed us to move from theoretical models of recovery time objectives and recovery point objectives and document them. And testing them before go live made sure that we had a well documented procedure that we could follow in case we had a disaster recovery scenario. Some of the lessons I'd like to share, what worked for us and what didn't work for us, and what we would do differently. I think the sequencing of choosing a two-phase approach is something that everyone asks us multiple times. Is it really worth doing it? But the biggest reason for doing that is risk decoupling. If you want to change your infrastructure, which is moving to cloud, and you want to change your runtime, which is moving from VMs to containers, and you want to change your data layer, moving to Postgres or Cloud SQL, all at the same time, it's a recipe for something to go wrong, right? And then when troubleshooting such a service, it becomes very complex because you're trying to figure out where the issue happened between a network configuration, a resource limit in a pod, a syntax error, or so decoupling them and doing phase one as a lift and shift helped us isolate the cloud infrastructure variables first. So in phase one, by moving to cloud, we were then sure that the cloud infrastructure fundamentally worked well for the service. And as I mentioned, it allowed us to measure the baseline. And this was our insurance policy. It allows us to prove to the stakeholders that cloud was just as stable as the VMware environment, and also gave the project team a breather to design the modernization. And like I mentioned, the modernization effort is a lot more easier with cloud native tools. And there are lots of these tools for cloud networking, IAM models, Kubernetes manifests, Istio service meshes. So decoupling is one of the key reasons why we chose the two-phase approach. Let's talk about some of the things that we would do differently if we were to do this again. One of the hardest thing I mentioned was doing the data change, right? The data migration from Oracle to Postgres. And if we were to do this differently, maybe we would start the database schema simplification work stream much sooner. We spent a lot of time in phase two fixing the Oracle specific things that needed to change to Postgres. Maybe if we had started this much sooner, maybe even in phase one, and let it land in phase two, that would have been a lot better, I would think. Secondly, observability. We waited until phase two to implement some of the more advanced distributed tracing. In hindsight, we should have instrumented our monolith with tracing before phase one. Having those traces, even in the lift and shift phase, would have helped us identify a lot of these latency jitters much easier. And on cloud, there's a lot of excellent tooling to help us do that. And that would have also benefited operating the service after phase one. Long story short, the key takeaway here is your migration sequence should be designed to build confidence both in the system's performance and your team's ability to manage it. So don't be afraid to take the slower phase route if it guarantees a success arrival, which has all the benefits that you want to get out of the project. So now I'll talk more about the SRE parts of operating in a containerized workload. As we move to GK, some of the valuable lessons we learned of operating at scale. Firstly, resource management. In the VMware world, we were always used to over provisioning because we wanted to make sure there was enough headroom for the service. In Kubernetes, that's not a great recipe. We wanted to use the best practices, which involved learning to set requests and limits based on our 95th percentile. And the success metrics we gathered in phase one helped us set those values in a much more well-managed way before we launched. We also were able to implement GK's autopilot feature to help us fine-tune these over time and grow as the business necessitates. Secondly, the deployment strategies. We moved away from maintenance windows. So by using GK's tested slow rollout deployments, we could spin up a new version of the system, new version of the containers, run through the tests, and then flip the traffic as they move, as they're being deployed. If there was a new bug detected, we'll roll back and the load balancer toggles away automatically. Thirdly, observability. In a monolith, we usually had logs in multiple locations, and it was always a challenge to go fetch those logs and look at them and correlate them with each other. In Kubernetes, logs are all centralized on Google Cloud Logging. These logs are all aggregated and helps us process bugs and troubleshooting much faster. Without these logs in a central area, it's almost like you're flying blind. So the central logging through GKE is really advantageous. And finally, on state management. So one of the most significant mindset shifts we had when moving from VMware to Kubernetes is how you handle state. So in our legacy VMware environment, we had every server was essentially a pet. We had a name, an IP address, we had data tied to that machine, and then we had to manage that machine. But with GKE, everything is deployments, so you have to manage the state of those deployments. They are both stateless assets and stateful assets. So clearly drawing the boundaries around each of these asset groups and managing them as states is the way to go. And this will allow you to scale horizontally and survive failures a lot more easier. The next thing I want to talk about is security. So security in a cloud native environment is not a perimeter you build your application around. It's a series of layers. So you'll build layers and layers of security. Like I mentioned in the legacy VMware setup, it was all about defining a boundary. And if you're inside that network boundary, you are trusted. But if you're outside, you're not trusted. In GKE, that model is very obsolete. There's a zero trust architecture, and we had to break it down by these pillars. You have identity access. So we moved away from long-lived service accounts, which were essentially latent credentials, and we implemented GKE's workload identity, which allowed us to have a service account that acts as a Google IAM service account. It also meant our pods get short-lived automatic rotated tokens. This allowed us to have the principle of least privilege. And if a pod doesn't need to write to a Google Cloud Storage bucket, essentially, like we wouldn't permit that through the identity account. Secondly, the network controls. Like I mentioned in phase one, we had these broad firewall rules, but in phase two, we implemented GKE's network policy rules. This allowed us to microsegment at the individual pod level. We were able to map all the traffic between the 200 different pods and the communications that they had. And we were able to define how these pods should interact with each other very specifically. And we also were able to implement like the default deny policy such that even if one pod is compromised, that's the only border in which the attacker is trapped onto. Thirdly, container security. We shifted left, which means that we were able to build all our container security well ahead into the development cycle. So we implemented image scanning for vulnerabilities. We were able to implement binary authorization. So these would prevent vulnerabilities even before it hits the container registry from where your images get deployed. So even in the build cycle, we were able to implement these controls so that the images were attested before they reached production. Finally, data protection. We shifted from manual certificate management to automated MTLS. So all data in transit and all data at rest is encrypted with the customer managed keys. And those keys were all managed by us in the GCP projects. So some of the practical takeaways that I'll mention. As I wrap up, I want to leave you with these 4 areas that will make any modernization successful. So start with the dependency mapping. This is one of the most underrated areas for SREs. It's necessary to understand the network flows, the application flows, and discovering hard-coded IPs later in the migration is a recipe for disaster. So understanding who all depend on this system, which systems does this system depend on is really necessary. Measure. So this is all the telemetry, all the metrics, all the baselines that you need to build. SREs have the 3 basic metrics, which are errors, throughput, and latency. So measuring that is a great starting point. Also, having a good set of baseline metrics ensures that you don't run into those conversations of someone feels like the app is slower with the migration. Having a baseline metrics helps you to have more objective data driven conversations rather than subjective feedback from customers. And like I mentioned, plan for the database complexities. Applications are easy to rewrite and re-architecture. Data is a lot harder. As we moved from our experience, it took us a lot of time to do this part. There are many cycles of repeated performance testing and feasibility that needs to happen to get to the point of completion. So start early, and if you end up finishing sooner, you can always use the time for more performance tuning. And lastly, like I mentioned, testing your disaster recovery scenario. I cannot stress this enough. Having a system that is only theoretically set up for a disaster is a liability. Like I mentioned, at Google, we periodically run Wheels of Misfortune disaster recovery testing cycles, where we break things on purpose in real environments. And if we challenge our teams to go ahead and try these disaster recovery scenarios within the RTO, test the playbooks, and then write retrospectives on what went wrong. So testing your DR periodically is a fantastic way to ensure that you have high confidence in your DR strategy. And like I mentioned, modernizing any legacy application service is a marathon. It requires patience, a phased strategy, and a relentless focus on automation. By decoupling the migration from transformation, we reached a goal of minimal downtime and a service that is ready for many decades to come. Thank you so much for your time today. I'm happy to answer any questions if you have any.